Thank you so much, my dear friends, for tuning in to this channel. My name is Darlin Fee. I'm so excited that in this presentation, we want to teach a very simple way of solving any question involving polynomial. And this is part 3. And so kindly make sure if you have not watched the first two, please do so. And if you have not subscribed, in order for you to get updates on all the exciting presentation we are doing on this platform, kindly make sure that you subscribe to this channel. If you have any question, drop your comment and I can assure you that your comment will be answered. Now we have these beautiful questions that we want to deal with. We want to make it very easy for all of us to understand. So if p of x is equal to x to the power 5 minus 1 and k of x is equal to 1 minus x, determine p of x over k of x. We will treat this, and then these are very exciting, and so if you are ready, let's go. So the first presentation is this. If p of x is equal to x to the power 5 minus 1 and k of x is equal to x minus 1, determine p of x over k of x. Certainly we are talking about the quotients, and so the diagram you see on your right hand side, it is what we are going to use in solving this. And if you understand less than 5 seconds, you should be able to produce your answer. So let's look at the question. First of all, if p of x is being divided by k of x, that means k of x is a factor of p of x. So this is k of x. So that is the factor of the p of x. Now in dealing with factors, according to the factor theorem, we will need to equate x minus 1 is equal to 0. So we can determine the value of x. And you know that x minus 1 is equal to 0. When we group like terms, we are going to get x is equal to 1. So that 1 is what we see here. Okay, that is outside what we see on the right hand side. So this 1 is coming from this x minus 1. So you make x the subject and then you are getting x is equal to 1. Then what we see here, the 1 0 0 0 0 0 minus 1. How do we get this? Now we are getting this from the p of x, that's the function. Now if you take a good look at it, x to the power 5. Now we don't have x to the power 4, x to the power 3, x to the power 2, and then x. We don't have them. Now from what we have established in the first two parts, we are saying that if a particular degree is not in the question, we assume that its coefficient is 0. Okay, so if that degree, okay, is not part of the question, then we assume that its coefficient is 0. So in the case of x to the power minus 5, its coefficient is actually 1. So that 1 is what you have here. Note the difference between this 1 and then this. This 1 is the coefficient of the function, this the highest degree. So the 1, the x to the power 5, its coefficient is 1. So that 1 is this. And then the first one outside here is coming from the factor. You equate this to 0, and then when you solve for x, you will get 1. So if you solve for x and you get 3, that means here will be 3. You solve for the x, you get 10. That means here will be 10. But in this question, x is equal to 1. So we have this 1 here. And then this 1 is actually the coefficient for this particular x to the power 5. Now, from x to the power 5, we should have moved to x to the power 4. But it is missing in the question. So using the synthetic method, once a particular degree is not in the question, we assume that its coefficient is 0. So the coefficient for x to the power 4 is 0. So that 0 is what we see here. And then from x to the power 4, we should have had x to the power 3. That one too was not provided. And so its coefficients we assume to be 0. So that 0 is this. Remember once again, x to the power 5 coefficient is 1. x to the power 4, which is not in the question, its coefficient is 0. X to the power 3, which is also not part of this question, its coefficient is 0. So we have it here. And from x to the power 3, we should have moved on to x to the power 2, which is also not in the question. So we assume that its coefficient is 0. So that one too, we have it here. So 0. And then from x squared, the next one should have been x, but the x is also not in the question. So we also assume that its coefficient is 0. So we have that 0 here. And then this minus 1, its coefficient here is minus 1. So let's go over this to establish a very important foundation. X to the power 5, coefficient is 1. X to the power 4, coefficient is 0. X to the power 3, coefficient is 0. X to the power 2, coefficient is 0. And then x, coefficient is 0. And then we have this negative 1 is what we see here. So that explains how we got the first row. Now we move on to the next. From part 1 and part 2, you establish that the very first coefficients, okay, the top one inside, you always bring that one down. So this one is what we are seeing here and nothing else. So this one, you bring it down. And then all the items down here, we are going to multiply them by the number here. And so this 1 times this 1 will give us 1. You move to the right hand side, the next number. So 1 times 1 is 1. That 1 is what we see here. Then once we have written this one, we add these two. 0 plus 1, we are getting 1. And for the down one, whatever you get, you multiply that with this one. So this one here times this one, that will give us 1. So we move on to the next number on the right, and then we place it under it. So this 1 times this one, we are getting this one here. And then once we have written this one, we add the two numbers. 0 plus 1, we are getting 1. And then remember, all numbers here must be multiplied to this. So this one will now multiply the one here. So 1 times 1, we are getting 1. So on the next number on the right, under it, you put it there. So this one, 1 times 1 is 1. It is coming now under this. And then here again, once you put it here, you add. So we are adding 0 plus 1, we are getting 1. And then this one will be used to multiply the one here. So 1 times 1, once again, we are getting 1. So on the right hand side, under the next number, you put it there. So 1 times 1, it is 1. So that 1 is what we see here. Then you add these two. 0 plus 1, we are getting 1. And then this one will be used to multiply the one here. So 1 times 1, that will give us 1. And then we add these two. Minus 1 plus 1, we are getting 0. So it means that the remainder, when x to the power minus 5 minus 1 is divided by x minus 1, the remainder is 0. So that's what we get here. Now the key concept here is that all the numbers that you write here, after writing them, add it to the top one and then write the answer down. And the answer you write down, you multiply it by the number you have here. And so 1 times 1, then the product, it goes to the next number on the right. You write it below it. So ladies and gentlemen, that is how come we have gotten this beautiful expression. Now we have also established, okay, that after getting all your answers, you are now going to assign degree, okay, to all the numbers here. So 1, 1, 1, 1, 1. We are going to assign degree or exponent to all of them. But the first one will have an exponent one less than the one in the question. So in the question, the highest degree is 5. And so the first number we have here, each degree is going to be minus 1 of the highest degree. So if the highest degree in the question is 5, and so 5 minus 1, that will be 4. That means here is going to be x to the power 4, and then x to the power 3, x to the power 2, x to the power 1, and then we have 1. So now let's add the powers to it. So adding x to the power 4 to this, we are getting x to the power 4. Adding x to the power 3 to this, we have x cubed. Adding x squared to this, okay, multiplying x squared to this, we are getting x squared. And then multiplying 1 by x, we are getting x. And then this one, we have it here. So that is quite simple. And so when you divide k of x, when you divide p of x by q of x, the answer is going to be x to the power 4 plus x cubed plus x squared plus x plus 1. And so we go to the possible answers and see which of these actually carries with this. Now, if you are doing this for the first time, it may look a bit difficult, but once you get the concept, 5 seconds is enough for you to finish it. So going through it, I can see clearly that the best answer for this is going to be the option C. And so the answer is option number C. And it is quite simple that we should be able to get it done. Now we move on to the next presentation. Let's now move on and deal with it. So given that k of x is equal to x minus 2, is a factor of f of x is equal to 2x to the power 5 minus x to the power 4 minus 7x cubed plus x squared plus 7x minus 10. So if you get it clearly, we are being told that k of x is a factor of f of x, which simply means that the k of x is dividing the f of x. So when that division takes place, what will be the factor? So this is what we are now going to do, basically to determine the value of it. Now we are still using our presentation. So let's go. First of all, you need to equate the factor to 0. Okay, so here the factor is x minus 2. You equate to 0. And then you find the value of x. So x minus 2 is equal to 0. If you make x the subject, you are going to get 2. Okay, so that 2 is what we see here, the first one. Always when you equate the factor to 0, whatever you get, that becomes the first item you are going to write. And now these other items are going to be the factors they are going to be the coefficients in the question. So in the question, we have x to the power 5. Its coefficients is 2. So this 2 is what we have here. And then x to the power 4. Its coefficients is minus 1. So we have minus 1 here. And then x to the power 3. Its coefficients is minus 7. So we have it here. And then x squared. Its coefficients is going to be 1. So we have the 1 here. And then x, the coefficients is 7, so we have 7 here. And then the last one is minus 10, so we have it here. So basically all these numbers are coming from the question. Now look at the degree from 5, 4, 3, 2, 1. So you see all of them are there. Now if any of them were to be missing, we would have assumed that its coefficients is 0. But thankfully all of them are there. So there's no assumption here. So that is how come we got these things. As usual, the very first number, not the one outside, the very first number, that is 2, you bring it down. So we have 2 down here. Now after bringing it down, you are going to multiply this one by the 2 here. So 2 times 2, that will be 4. So it should be written on the number at the right hand side below it. And that number is negative 1. So 2 times 2 is 4. So 4 comes under negative 1. After writing this 4, you are now going to add the top and the down. So minus 4 plus minus 1 plus 4. That will give us 3. So this is okay. Now once you write any number down, that number must be used to multiply this. So 2 will now multiply 3, will have 6. So it will go to the next number below it. And the next number is minus 7. So below it is here. So 2 times 3 we have 6. So we have it here. After writing this, we add the two numbers. Minus 7 plus 6. We are getting minus 1. Okay, so this number 2 will be used to multiply the number outside. So 2 will multiply minus 1, and that will give us minus 2. And then we add the two numbers, 1 minus 2, we are getting minus 1. And then once again, whatever you write down must be used to multiply this. So 2 will multiply negative 1, and that will give us negative 2. And then we have to add the 2. So 7 minus 2, that will give us 5. And then this 5 will be used to multiply these 2. So 2 times 5 will give us 10. And it will go below the next one. So that is 10 here. Now we add these two. Minus 10 plus 10 will give us 0. That means when f of x is divided by g of x, the remainder is going to be 0. Once again, I encourage you, if you haven't watched the part 1 and part 2, for better understanding, kindly do so. So this is the remainder. Okay, and then we have said that after dividing through, now we are going to assign x to the power something to all these things. So we start with the first one. Now the degree of the first one must be always less than the highest degree, okay, in the question. So the highest degree in the question is x to the power 5. Okay, and so that means minus 1 of this will give us x to the power 4. So it means this one will take 2x to the power 4, and then this will be x to the power 3, then x to the power 2, and then we have x. So multiplying 2 by the x to the power 4, we have 2 to the power 2x to the power 4, and then this is 3. That's so we have 3x cubed, and then this is negative 1, so you add x squared. Remember, you are reducing it, okay, the degree. So from power 4, power 3, power 2, and then this is power 1, and then power 0. So we have x to the power 4, 3x cubed, and then this is going to be minus x squared, and then minus x, and then plus 5. So this is how easy it is, and you can always use this, but for the sake of examination, you need to practice. Make sure you master the act of doing this, rather than going through the long divisional method that we were taught in school. You can use this, and it is quite simple. And once again, my name is Dalen Fee.